Hello and welcome to the last module of our discussion on inventory models with probabilistic demand. Now, as you can see, we are calling this module product availability. And what do we mean by product availability? Now, if you remember, one of the realities that we have introduced in our probabilistic demand models is the event called a stock out, which means that there is a probability that there might be a stock out during any cycle. Okay, and if there is a stock out, then the product is not available to the customer, and therefore product availability becomes an important consideration because it denotes how much of the demand are we able to meet with our inventory, because we know that we can't meet 100% of the demand. Okay, so having understood basically what availability is, we are going to measure, or we are going to use two metrics for measuring availability of product, and these metrics are, as you can see, cycle service level and item fill rate. Okay, now what is cycle service level? The probability that there will be no stock out during a cycle. Suppose I say that the cycle service level is 90%. What it means is that 90% probability that there will not be a stock out during the cycle, which means 10% probability that there is a stock out. If you relate this to our earlier discussion, we called the probability of a stock out alpha. So when we say CSL is 90%, we mean that our alpha is 10%. Okay, we will of course go ahead and understand CSL a little more in detail soon. Okay, what is the other way of measuring availability? We are calling it the item fill rate. And what does it represent? It represents the proportion of the total demand that is met with the available inventory. If the demand is 100, are we meeting 100 of 100? No, we are not. It is not possible, like I said earlier, to meet 100 of 100. Are we meeting 95 of 100? Probably. So if we are meeting 95 out of 100, of the total demand, then we are having an item fill rate of 95%. Okay, like I said, let's understand these more in greater details. I will soon show you an example. So here we are, cycle service level. I had said that alpha is the probability of stock out, and therefore what is 1 minus alpha? 1 minus alpha is this area which is not shaded, okay, and that is my CSL. So CSL actually represents the cumulative probability from minus infinity till this value of alpha, okay, and so if alpha is 5%, then obviously my CSL is 95%. So given a CSL of 95%, can I calculate my Z alpha? Oh yes, of course. I just need to go to my standard normal table, look at a cumulative probability of 0.95, and corresponding to that 0.95 cumulative probability, whatever is the Z value is my Z alpha. Okay, so let us be very clear. We are using the product availability measures to finally find Z alpha. That is the objective. Okay, good. Now, why don't we have, what is CSL? CSL is a policy decision. The company has to decide, the top management or whatever, they have to decide what their target CSL is. Why can't it be 100%? After all, which company would say that, I don't meet 5% of the demand or 2% of the demand or 10% of the demand? And we have already discussed that, the normal distribution curve, is asymptotic. It never meets the horizontal axis, and therefore you can never have 100% CSL. So you'll have to decide how much CSL you want. Now, a very interesting question here is that, is it an arbitrary number? Do we just go ahead and say, oh, let it be 90% or let it be 99% or 95%? What really determines this 95% or 99% or 90%? To understand that, let's say that I increase my CSL. Now, the more I increase my CSL, what happens to my Z alpha? My Z alpha also increases. The more I increase my Z alpha, what happens to my safety stock? My safety stock is Z alpha into sigma DL. So obviously my safety stock keeps on increasing. So the more I increase my CSL, my inventory level goes up, and therefore my inventory carrying cost goes up. Okay. Now, what is the other side of the picture? If I reduce CSL, suppose I reduce CSL, I want to reduce my inventory carrying cost. But if I reduce CSL, what am I doing? I'm increasing the probability of a stock out. And therefore, the CSL is a fine balance between two costs. One is the cost of carrying inventory, okay, because if you increase your CSL, you are carrying inventory. And the other is the cost of a stock out, because if you reduce the CSL, there's a greater chance of a stock out. And therefore, if you remember single period inventory, we had talked about critical ratio, where we talked about the shortage cost and the excess cost. Here also, we are talking about shortage and excess cost. And we are saying that the CSL is actually a balance between the shortage and excess cost. Okay, but having understood what it is, we must then also understand that it is a number which is fixed by the company management. Good. So given a CSL, we can very easily find Z alpha. Now, let us look at this example to understand the difference between CSL and item fill rate. So what we have is, we have two products, product A, product B, and we have some data for 12 months, Jan till December. Now, what data is this? We have orders placed on product A or for product A and for product B. We have orders placed for these products, and we also have the corresponding supplies that are made each month. Okay. Now, assuming that the cycle is of a month, then we are saying, what is my CSL from this data? Okay. Now, if you look at the data, in January, I met the demand, oh, I fell short, 180 versus 200. So there must have been a stock out here. So here is one stock out. Here is another stock out, 240, 250. Okay, so 1, 2 stock out. And here is another one, 3 stock out. Okay, so that's it. So we have 3 stock outs in a period of 12 cycles. So out of 12 cycles, we stocked out in 3 cycles. And therefore, what is my cycle service level probability of no stock out? The probability of no stock out is 9 out of 12, because we did not stock out in 9 out of those 12 cycles. Okay, 9 out of 12 is a simple calculation that gives us 75%. So our CSL is 75%. Okay, now let us come to the item fill rate. What is the total demand during the 12 periods? The total demand is the sum, this plus this plus this and so on. If you sum all the orders, you will know what the total demand is. And what is the total supply? Well, you sum the next set of numbers and you get the total supply. And if you did that, you will find that for product A, the total demand was 1900 units and total supply was 1820 units, and therefore item fill rate was 1820 divided by 1900 or 95.79%. And what is item fill rate? Item fill rate is the proportion of the total demand that we are able to meet with our existing supplies or with our stock. Okay, so that's the basic difference between CSL and item fill rate. And here we are saying that usually the CSL will be less than the item fill rate. Why are we saying that? Now, to understand this, let us go back to our example. Okay, let us look at the month of March. Now, the month of March for CSL calculation will be counted as the full month as stocked out. You know, we have 12 periods. Now, this is one period gone, stocked out. Okay, whereas from a item fill rate, we actually met 90% of the total demand. This is 180 and this is 200. So we met 90% of the total demand. So what if we stocked out? You know, so for periods where you stock out, even if you fill 99.99% of the demand, you will stock out. So therefore, the stocked out period will be counted as 1 in CSL. But even in that period, there can be high high level of item fill rate because you might have filled a large proportion of the demand during that period. Okay, so that is the reason why usually you will find that the item fill rate will be higher than the CSL. Okay, good. Safety inventory versus CSL is something that I did. I calculated for different values of CSL. Okay, I assumed some sigma D and L. Okay, I actually assumed a sigma D of 100 units and a lead time of 4 periods. Okay, if you did that, different CSL values will give me different Z alpha. I can calculate Z alpha here, Z alpha here, Z alpha and so on. And then using Z alpha and sigma D and root L, I calculate the safety inventory. These are the values here. And if I plot this here, you will find that the safety inventory goes up like this. As you increase your CSL, the safety inventory goes up exponentially. Almost. You know, which means the reason I'm showing you is that it is very easy for us to say, oh, why 95%? Why not 96%? Why not 97%? Well, if you want to do 96%, 97% or whatever, the cost, the inventory cost rises disproportionately. That is the reason why we have to be careful about fixing our CSL level. Okay? Now, finally, I come to item fill rate. We have discussed, we have defined what item fill rate is. Now, I said that our objective is that given an item fill rate, I should be able to calculate Z alpha. We have already discussed the CSL, situation. Given a CSL, how to calculate Z alpha, we know. Now we are going to discuss, given an item fill rate, how do we find out our Z alpha? Okay, so we are saying item fill rate is equal to 1 minus expected units short upon Q star. Now let me explain this a little bit. Why are we saying this? How do we get this? Okay, now what is the average demand during a cycle? We have seen that the average demand during the cycle is Q star for continuous. Let's look at it as a continuous review policy right now. So the average demand is Q star during a cycle. Okay. Now, how much of this demand are we able to meet? The demand we are able to meet is Q star minus expected units short. If we go short, for example, there is always a probability of stocking out, so you go short. Okay, so the expected unit short. So Q star minus expected unit short gives me the total sale. We have done this earlier in single period inventory. So sale is the total quantity that I actually sell, or supply. And what is the demand? The demand is Q star. So this divided by Q star tells me what fraction of the total demand during the cycle am I able to actually meet. So Q star minus expected unit short upon Q star, and that gives us 1 minus expected unit short upon Q star. Okay, that is exactly what we have here, 1 minus expected unit short upon Q star. Now the question is, what is expected unit short? How do we find it out? Well, from single period inventory discussion, we know that expected unit short is sigma times the loss function, and this is sigma DL, by the way, DL. Be very careful, we are talking of sigma during lead time, not sigma per period. Okay, so sigma DL into GZ, and you know, so if I put sigma DL into GZ here and rearrange, we will get GZ is equal to Q star upon sigma DL 1 minus IFR. Okay, so therefore what we are saying is very simple. If we are given IFR and we know sigma DL and Q star, then I know the right hand side of this equation, and that gives me the value of the unit loss function, and from the table of unit loss function I can find out the value of Z also. Okay, so let's take an example, a numerical example of how we do this. So I have a problem statement given on the screen. Let me read it out. You are managing the inventory of a production part with annual demand normally distributed with a mean of 62,000 and a standard deviation of 8,000. The cost of the item is $100 and the holding charge is 15%. Let's understand that this is the annual holding charge of 15%. You have determined that the economic order quantity is 5,200 units. That means we are given Q star. The lead time is 2 weeks. Assuming IFR or the item fill rate of 99%, can we find out the appropriate SQ policy? SQ policy in this case is the continuous review policy, where S stands for the reorder level and Q stands for how much we are ordering. So when we are ordering, how much we are ordering. Okay? Okay, so, you know, in order to find out S, small s, what is small s? We have already seen my small s is equal to sigma D into L plus Z alpha sigma D into square root of L. Now, I need Z alpha to find out small s. That is the crux of this discussion. Okay, so how do I find out Z alpha? I find out Z alpha from the value of GZ. But how do I find out GZ? Well, I find out GZ, I am given IFR. IFR is given 99%. So 1 minus 99% is 1%. Q is given. Q, 5,200 units. That is my order quantity. What is my sigma DL? My sigma DL is sigma D into root L. Okay. Now what is sigma D? Sigma D is 8,000. But we have to be careful. This demand is the annual demand, whereas the lead time is 2 weeks. So when we say sigma D root L, we have to convert our demand into weekly demand and then multiply it with square root of 2, or we need to retain our annual demand but convert the lead time into annual. Okay, so we have to be consistent with the units. So what is our annual sigma D? Our annual sigma D is 8,000 units. What is the square root of L? My lead time is 2 weeks, but I need to convert this into annual lead time. So 2 divided by 52, if I assume that there are 52 weeks during the year and all 52 weeks are working weeks, then This is 8,000 square root of 2 divided by 52. And if you did that, you will find that your sigma DL comes out to be 1,569 units. Okay, so 5200 is the value of Q. 1569 is what we calculated as sigma DL. 1 minus 0.99, because 0.99 is the IFR, we get a value of 0.0331. That is the value of GZ. Okay, so we have been able to calculate GZ. 0.0331. Let me show you the corresponding table here. Now the third column here are the GZ value column, and the first column are the Z value column. So where do we see 0.033, 0.04, 0.037, 0.034? Looks like somewhere here, 1.44 or 1.45 is the value of Z when GZ is 0.0331. So therefore, if we go back, I have taken the Z value as 1.45, and that is what we all need to find out the value of small s. I haven't calculated small s here because that was not the purpose. The purpose was to show you how to use the item fill rate to get the Z value so that we can use it to calculate our small s. Okay, so what do we have next? Well, thank you. That is the end of this module, and that is also the end of this topic.